Hey guys, Miss Varian here. We're going to look at Unit 2, Note 6. We're going to solve single-step and two-step radical equations. So radical equations are just things we've been looking at, equations that have this symbol in it. So we're going to solve for a variable, just kind of like the steps that we've been doing, but we have a couple extra ones that we need to know because we'll have radicals this time. So here's the steps you're going to go through. Is anything being added or subtracted? Now, when you're looking at is anything being added or subtracted, you're looking on things that are outside the radical, okay? So if I give you this and then I have plus 3 at the end, this is not underneath the radical, so that's outside the radical. That's what we have to get rid of first, okay? Then we're going to get rid of anything that's on the outside of the radical, maybe in the front, by either dividing that out, okay? Because this is saying 3 times this radical, so to undo multiplication, we would divide that out. Then this is the piece that's new to you right here, this number 3. How do we get rid of a radical? You need to use the opposite operation. So the square root and something squared cancel each other out. So these two things are opposite operations, and those two things cancel each other out. Just like if you have a plus with a minus and those cancel each other out, or a multiply with a divide, those cancel each other out. A square root and a square are inverse operations, so they cancel each other out. Your last step then is always to plug your answer back into the original equation to check and see if it's true. If it's not true, then your answer is no solution. Okay, so it's going to be really, really important that you check your answers to see, does it fit into the original equation and make a true statement or not? So let's go ahead and look at this example here. So here's how I kind of always look at these. I go ahead and I highlight the radical, okay, and everything that's underneath the radical. That is what we're trying to isolate and get alone. So things that are outside that I need to get rid of then is this minus 7. So to get rid of minusing 7, just like before, we add 7 to both sides. So these are going to cancel and we're left with the square root of x equals 7. So I want to see, is everything I highlighted from before alone? It is. At that point, when everything that you've highlighted is alone, that's when you're going to square both sides. So I'm going to square both sides. What that's going to do is the square root and the square are going to disappear, and I'm left with only what was underneath the radical. In this situation, that's just x. It doesn't change anything. It's just copy exactly down what was underneath it. 7 squared is like saying 7 times 7. So I know that 7 times 7 is going to give me 49. So now I'm going to take that 49 and I'm going to plug it back in, and I'm going to see if it gives me a true statement. So I'm going to have the square root of 49 minus 7 is going to equal 0. So I know that the square root of 49 is 7. I have that minus 7 equals 0. Well, 7 minus 7 is 0. So this is a true statement. So this is my final answer. Let's look at another example here. 6 plus the square root of x equals 13. So again, I'm going to highlight the radical and everything underneath it. That's what I'm trying to get alone. So I know that I have to get rid of this positive 6 on the outside. So to get rid of positive 6, I'm going to subtract 6. What I do to one side, I have to do the other. So these are going to cancel, and I'm left with the square root of x equals 13 minus 6, which is going to give me 7. At this point, everything that was highlighted is what's alone. So that's where I can square both sides. So the square root and the square cancel each other out, and I'm left with just x. 7 squared is going to give me 49. So again, before I can tell if this is my answer or not, I have to plug it back into the original equation and see if it's true. So I'm going to 6 plus the square root of 49 equals 13. So 6 plus 7 equals 13. Well, 6 plus 7 is 13, and that does equal 13. So it's a true statement, so this is my solution. Let's look at number 3 here. I'm going to go ahead and I'm going to highlight what's underneath the radical, and so what's not highlighted I need to get rid of. So I need to get rid of multiplying by 3. So to get rid of multiplying by 3, I'm going to divide both sides by 3. So those are going to cancel. I'm left with the square root of x is going to equal 1.33, repeating, but we're just going to leave it as 1.33 just for the sake of this. Right now what's highlighted is alone, so I can square both sides. Those are going to cancel. I'm left with x equals, I'm going to type in 1.33 squared, and I'm going to get about 1.78. So I need to check and see if that's true or not. So I'm going to plug it into the original equation. 3 square root of 1.78 equals 4. Now, 1.78 is not one of our perfect squares from before. So if you don't know how to find the square root button on your calculator, please come and talk to me. Okay, it is the second button and then the x squared button. Okay, and that's going to give us the square root. And then we can type in 3 or 1.78. So I'm going to have 3 times 1.33. And we want to see if that equals 4. Well, that gives me about 3.99. And because we rounded over here, that is just an error, not an error, but that's just because we rounded. So it is saying that 4 equals 4. That is close enough for us. So that is a true statement. So this works. All right, let's look at this example here. I'm going to go ahead and I'm going to finish solving this. Now, I am going to highlight what's underneath the radical. And this tells me that I have to get rid of multiplying by -5. So I'm going to divide by -5 and divide by -5. So the square root of x is going to equal -6. Now, at this point, I can tell you right now that I know that this is going to be a no solution. Okay, this problem is not going to work because you cannot, when the highlighted piece is alone, you cannot have it equal to a negative number. Because there is no number that I would plug in that would give me the square root as -6, right? We know that the square root of 36 is +6, but the square root, we can't figure out any number that we can take the square root of that would give us a -6. So if I were to square both sides, okay, right here at this point, I would say no solution, but I want to show you exactly how this works, okay? If you square both sides, you're going to end up with x equals 36. So if I plug that into here, -5 times the square root of 36 equals 30. Well, I know that square root of 36 is going to give me 6. So I'm going to end up with -30 equals +30. That is not a true statement. So since that's not a true statement, again, that tells me it is no solution. So this does not work out, and my final answer is that no solution. But I could tell you that right here, when I got the square root of a number equals a negative number. Anytime you see that, you could probably say no solution right away and be done. Let's look at this example. I'm going to highlight what's underneath the radical and the radical itself. That's what we have to get alone first. So we always get rid of the adding or subtracting first. So I'm going to get rid of this +4 on the outside by subtracting 4. So I'm going to have 2 square root of x equals 11. Now I'm going to get rid of this multiplying by 2 because, again, here's what we're trying to get alone. This I need to get rid of by multiplying by 2 by dividing by 2. So I'm left with the square root of x is going to equal 5.5. So now, since that highlighted piece is alone, I can square both sides. Decimals are fine, you guys. Nothing is wrong with decimals. If I plug 5.5 squared into my calculator, remember that's 5.5 times 5.5. I'm going to get 30.25. So we're going to check that out with our original equation, see if that's a true statement. So 4 plus 2 times the square root of 30.25 equals 15. So plug the square root of 30.25 into your calculator, and you are going to end up getting 5.5. We always want to multiply before we add. So I'm going to have 4 plus 11 equals 15. So now 15 is going to equal 15. That's a true statement, so this is my final answer. Last one here, let's go ahead. We're going to highlight that piece there. And we're going to get rid of the things on the outside. So I'm going to get rid of whatever's being added first. So I'm going to get rid of that by subtracting 16. So I have 3 square root of x equals -3. So at this point, people would say no solution, but careful. You have to have the highlighted pieces alone first, okay? And you're going to see this one actually is still going to come up as a no solution, but we can't tell that yet. We always have to get the highlighted pieces alone first. So I have to get rid of multiplying by 3 by dividing by 3. So I get the square root of x equals -1. Now we know right here, this tells me no solution, but we can always continue to solve. If we don't see that, solve and see if it works. So I could square both sides, and I would get x equals 1. So if we plug that back in, I'd get 3 times the square root of 1 plus 16, see if that equals 13. So 3 times 1 plus 16 equals 13. 3 plus 16 equals 13. Well, that's not true. I would get 19 equals 13. So that would be a false statement, which is, again, where I know that no solution is my answer. All right, we got some practice here to get to. If you have questions, stop and ask me. Good luck.